So where we're at so far is this little panel right here came out of a flashlight. It came out of a light just like this. Now this is basically what I was thinking in terms of a single person's portable unit. This one's got a hanger on it and a magnet. It's got a flashlight that comes out of the front, and it's got a flashlight that comes out of the top. Now as you can see, this is much brighter on 3 AAA batteries than the unit that we have right there. So we're working on that. But what we've got going on right here is actually really exciting. This is just one of our cells that's running this LED panel and this LED, which is a 5-volt LED, super bright. You can see, and it's pretty bright. I mean, there's some good light there, and that's also some very nice usable light. Now, it doesn't light up the whole room, but it will definitely light your way on a path, on a trail. So we've got this number of them delivering 30 milliamps at 1.05 volts to this circuit. These have been lighting for 4 days now. We got a lumen counter here. I'll show you what kind of lumens we're getting. I'll turn this on, and we'll put this like this so you can see it, and put that right over the top there. You can see that it's pumping out 280, roughly 280 lumens. So we got the lume counter here, and that's been telling us, what we're actually getting, because we're going to get an oscilloscope to work with, but the amp meter and the voltmeter only tell us so much. So there's a limit to what we can dig and find, but we are definitely getting a more efficient circuit out of this. In fact, I think with a few more of these crystal cells, I'll be able to get enough voltage to run this, which is at about 1600 lumens. This one's actually designed to be a grow light, but we wanted to use a good size panel for a test bed. So what we're going to try and do is get this one to run on just crystal cells with a joule thief circuit, just to boost it so that it gives off the same number of lumens, or close to the same number of lumens as it does when it's plugged into the 110. Now this is a really simple panel. It's just a driver circuit hooked up straight positive and negative to the entire board. So really simple. We're just going to create our own new driver circuit that makes it more efficient. The other thing is these panels are, this one's 14 watts, and these panels are a little bit harder to drive. So once again, we're probably going to need almost as much as we need to run this one, because each one of these actually comes off at about 1.5 volts. So it's going to be just basically putting them in series to jump up the voltage. That's going to be the next step. We're working to make a portable version, something similar to like this panel here. Now, I'm not arguing here that this is brighter, okay? So there's no argument there. But this is running on 3 AAA batteries that will go dead and have to be bought again, and are a resource. And if you're not in a place where batteries are readily available, things like that, then this light is just a paperweight once those are dead. But this one has been running for 4 days straight at 200 lumens. So it's a start. A couple of the things we've noticed is that there's a skin of resin or whatever that they put on the outside of these, just like magnet wire. So we cleaned them out really good with a wire brush. We tried heating them. Either works to get a better contact. So the conductivity to the surface, inside the surface of the copper, is important for, I suppose, the chemical reaction, which is the corrosion of both the copper and the magnesium. Now the thing is that it happens so slowly that it'll last for a very long time. How long, I'm not sure. Could be months, could be years. So this is just something really new, really fun, and we're wanting to get some of these panels that work like this into something that's portable, just like this, to be able to distribute in places where they don't have light. Because, I mean, if you can imagine, maybe not such a blue light, maybe a yellower light, so that it's more comfortable. You can like hang it from the ceiling or something like that. But obviously not in something that's driving one direction. This is more of a flashlight. So that's why we're looking at these types of panels that actually distribute usable light, like you would use for, your room or the kitchen, or in a hospital, in the field, where somebody desperately needs medical attention and the only light that you have is a kerosene lamp. Big difference. So with this. So these are the things that we're working on. This is what the whole idea behind Project Lightshare is about, is that this technology is possible, feasible, and working on a shoestring, on literally bootstraps. And we got this to work. It's running for 4 days straight now. Now we're getting 200 lumens. We have it in parallel with 5 of these units, which should be about the same as one when we get the construction exactly right. Other alternatives like that LED, one of these cells can slide right into here, and have a very small circuit that will actually run that LED indefinitely in a usable light. So thanks for watching.